How are the sequence networks connected in case of double line to ground fault? A. All in parallel. B. All in series. C. Positive and negative in parallel. Time's up. The answer is A. All in parallel. In double line to ground fault, positive, negative, and zero sequence are equal in voltages, which satisfies the condition of parallel connection of sequence network. Fault current in both the phases in a double line to ground fault have A. Same magnitude, different phase. B. Same magnitude, same phase. C. Different magnitude, same phase. Time's up. The answer is A. Same magnitude, different phase. In any three-phase system, the sum of ground currents is zero. As a result, in double line to ground fault, the two faulty lines carry equal magnitude but out-of-phase current, resulting in zero sum at ground. In double line to ground fault, the sequence voltages are such that A. All are equal. B. All are unequal. C. Only two are equal. Time's up. The answer is A. All are equal. The sequence network is connected in parallel, which shows equal sequence voltages. To account for the change in magnitude of voltage from low voltage side to high voltage side, which parameter is changed? A. The formula. B. Base value of power. C. Base value of voltage. Time's up. The answer is C. Base value of voltage. Base value of voltages is taken as the rated voltage of transformer. As transformer voltages change from low voltage to high voltage side, so the base value of voltages also changes.
In which case do we have to incorporate phase change in voltage when moving from low voltage side to high voltage side? A. When transformer connections are delta Y. B. When transformer connections are wye-wye. C. When transformer connections are delta-delta. Time's up. The answer is A. When transformer connections are delta Y. In delta, line voltage is equal to phase voltages, but in Y, line voltage is √3 times of phase voltage, so phase change is required in delta Y transformer connection.
Why do we have the negative sequence in front or ahead of a reference point, when the positive sequence is behind that reference point? A. Because negative sequence leads. B. Because negative sequence rotates in opposite direction. C. None. Time's up. The answer is B. Because negative sequence rotates in opposite direction. Positive and negative sequences are equal in magnitude, but their sequence of rotation is opposite, showing negative sequence ahead of reference point, while positive sequence behind the reference point. Which quantities do not change by changing the zone in the system? A. Base power. B. Base voltage. C. Base impedance. Time's up. The answer is A. Base power. In per unit system, we consider a common base power, so it does not change in any of the zone. How do we account for the phase change in positive sequence current when moving from low voltage side to high voltage side? A. Multiplying J. B. Multiplying A. C. Depends on transformer connection. Time's up. The answer is C. Depends on transformer connection.
In the case of wye-wye or delta-delta, there is no phase shift, but in case of delta-Y connection, there is a 30 degrees phase difference. By moving from low voltage side to high voltage side, we multiply by 1 less than minus 30 degrees in case of
A. Positive sequence current. B. Negative sequence current. C. Zero sequence current. Time's up. The answer is B. Negative sequence current, because negative sequence rotates in different direction. Why do we observe a voltage depression in one of the unfaulted phases on high voltage side in case of delta connection? A. Because of nature of fault. B. Because of transformer connections. C. None. Time's up. The answer is B. Because of transformer connections. Because the faulted phase of transformer is connected to the unfaulted phase on the other side of transformer in case of delta.
Hi, I hope you enjoyed this video and found it useful. Comment below and subscribe to our YouTube channel so you can get updates on whenever we post new content. Thank you and see you next time.